we're going to use the calculator to help us solve a little bit more of a complicated annuity immediate problem. So in this problem, we actually have two different annuities going on. We've got one that's going to pay $100 at the end of each of the next 5 years, and then one that's going to pay us $300 at the end of each of the 5 years following. So they also tell us that the annual effective rate in this case is 6%, and we want to know the present value. So we got a time value of money diagram set up here, where we've got $100 payments for the first 5 years, at the end of each of the first 5 years, and $300 payments at the end of each of the next 5 years. So one of the ways that you can think about this particular problem is I can think about moving the $100, this annuity, this 5 payment annuity, to time 0. And then I can think about moving this 5 payment annuity first to time 5 and then to time 0. So notice that each of these would be annuities immediate. We've got this annuity immediate here that's paying at the end of each of the first 5 years. So if I just do the present value of that annuity, that will take me back to time 0. Here's another annuity immediate. If I use find the present value of this using our A angle N formula, that will take us back to time 5. That puts it at the end of each of those time periods. Then I need to move it back another 5 years using our V to the N. So that's where this formula is coming from. The present value is going to be 100. That's the amount of the payment for the first annuity. A angle 5, because we've got 5 payments, and it's just A, not A double dot, because it's at the end of each period. And the interest rate is 6%. So this first part here is going to take this annuity and move it back to time 0. 300 for the next part, we got 300. That's the amount of the payment. Again, A angle 5. There's 5 payments using regular A, not A double dot, because again, I'm going to move that back to time 5. We're thinking of these at the end of each period. But then I've got to take that the value of that at time 5 and move it back to time 0. So this is the V to the N, V to the 5th, if you will, where V is going to be 1 over 1 plus I, the 1 over 1.06. So let's talk a little bit about how we can use our calculator to solve this. All right, so we're going to do a time value of money problem, so let's clear our time value of money. Let's do this in 2 pieces and use our store functions on the calculator. So we can actually store values in our calculator so that we don't have to write things down or retype things in again. So first thing I want to do is calculate this first part, this 100 A angle 5. So we want to do 100 as our payment. Our N is 5. Our interest rate is 6. So I'm just putting those in. And what we want is the present value. Present value comes out to be $421.24. Just for simplicity's sake, I'm going to take off the negative, and I'm going to store this in number 1 just to keep it. I just want to keep that value in there. So again, remember to store, I just hit STO, and then wherever I want to store it. Again, remember I can store it in any of these digits. All right, so for the second part then, I need to calculate the present value here using our time value of money functions, and then multiply by the V to the N. So let's clear this. Let's clear the time value of money. In this case, our payment is 300. The number of payments is 5. The interest rate is 6. And I want to compute the present value again. I'm going to make that positive. Now, this isn't the value I want to add to the previous one. I still need to multiply by the V to the N. So I need to take this times. I need to go 1.06, flip it. That's 1 over 1.06, and then raise that to the 5th power. I don't have mine in chain mode. I have mine in order of operations mode. If you have yours in chain mode, you'll need to make sure that you either put parentheses around things or store it. Okay, so this gives me the present value of the $300 payments back at time 0. So present value, honest to goodness present value here. All right, so now we're ready to add this to the previous one, the first part of our equation there, and get a present value of these payments to be $1,365.55. So again, we used our calculator here to calculate the present value of a couple of different annuities. And we use the store functions in our calculator to help us keep those values as we went along so that we can add them together at the end.